Okay, so welcome everyone to the solution video for contest weekly contest 329. So moving towards the third question. Okay, so what you were given was कि zeroth indexing के लिए के साथ एक string s and a target string you have been given with the length of them are same. Okay, so what we can do is we can select any ith और jth index मतलब कि कोई भी ith या jth index select करो and what you can do is for ith index you can replace ith index you can replace this one s of I with the or operation between the ith index and the jth index element मतलब कि just a second. Okay, so okay. So if I have a string, let's say this represents a string. I mean, what is a string? String is a character array, you know, an array of characters. So if I take this I and I take this as j, okay. So what you can do is for every, let's say this is s. So for every s of I, you can replace this with s of I or binary operation s of j. And for s of j, you can do what you can do is s of I XOR s of j. Yeah, these two operations, the first one and the second one, you have to do simultaneously. So this is what it is said here. Okay. So first of all, let's move to just a second. Okay, so first of all, let's move to what do you mean by XOR and OR operations? So let's say I have bit 1 and this is bit 2. Okay, so if 1 0 0 1 1 1 and what 0 0. So the OR operation is just like adding these two bits 1 0 1 1 0 1 1 1 1, what it will be 1 and then 0 0 0. But the XOR operation, the exclusive OR operation, it operates like you can use this hint. What is that hint? Like if you have let's say you have n bits. If you have n bits like this one, this is bit 1, this is bit 2, and like this if you have n bits. Okay, so what you can do is uh, if n, in these n bits, if you have odd number of ones, if you have odd number of ones, your XOR will produce an output of 1. If you have even number of ones, the XOR will produce an output of 0. This is what it is. So using this, you can do this 1 and 0. If you XOR 1 and 0, because here the number of 1 bits, the bit number of 1 bits are odd. So here it will be 1. The same way in this one, 1. In this you encounter 2 bits, which is 2 is even. So you will have 0. Here you have 1 bits. 0 itself is even, so it will be 0. So this was the operation that you were supposed to do. Okay. So moving to the next part of the question. So what you were given two strings, and you have to just make the string s equal to the target. String s equal to the target. मतलब कि कोई s string दी गई है 10100001 और लेट से कोई टारगेट दिया गया है 01001. Assuming that both these lengths are same, so you have to just convert this s into this using these two operations. Choosing any index I and j, and for ith you are doing or, and for jth you are doing XOR. So this is very much trivial. Like you can choose any I. Like let's take this example. 10. Uh, what is it? 1010 is my S, and my target, let it be represented by T. T, it is 0110. So what you have to do is just let's compare, every ith bit for this one, or every index for this index, the first one. The target has 0 and we have 1. So we know that if we have an OR operation, or we cannot produce a 0 with the OR. If you have seen this, like 1010 and then 0110. If you do OR here, 0 will be produced only if both the bits are 0. Either one is 1, मतलब एक अगर 1 आया तो 1 आना है, क्योंकि मोर ऑफ एडिशन ऑपरेशन हो रहा है उधर. So you cannot produce a 0th bit like in the target, as it is in the target 0. So what you can do is you can do an XOR operation. Why? We have 1, we have to produce 0. We have to take XOR with any 0. So if I take these both and I take the XOR, this being my jth and this being my ith. So I has to be replaced with OR. So if I take this one I and this one j, so I has to be replaced with OR. So 1 or 0, it will be 1. So I'll get 1, and the jth bit has to be replaced with XOR. So 1 XOR 0, it will be 0, and this these all, it will come like this all. And looks like we have achieved our target. So yeah, we will output a yes here. So what we can see here, what we can notice here is, like if we have any if we have even a single 1, if we have a single 1, we can produce any output, provided the target is not 0 0. This is the only exception. If we have s as 1 1 and the target as 0 0, whatever we do, we cannot produce this output. So that was the crux in this question. So what I did was, let's come to the code part. The C1 will be representing my bits, the 1 bits in string s. String s, the 1 bits will be represented by C1, and D1, the target bits, the ones in the target bits. So if it is, I'll increment C1, I'll increment D1. So if D1 is 0, like there are no 1 bits in D1, like it's all 0. So you cannot produce this one using XOR or OR operation. So either the strings are equal, if they are, well and good, otherwise false. And other than that, if C1 is greater than 0, then yeah, you can produce. Like if there are none, like if there is 0 0 in S, if S contains 0 0 and if T contains 1 1 1, you cannot produce 1 1 1 with 0 0 0 with any operation. बस अगर और कर रहे हो या अगर जोर कर रहे हो, अगर और कर रहे हो तो या तो दोनों बिट्स 0 हो तब तुम्हारा 0 आ जाएगा. अगर जोर कर रहे हो तो ऑड नंबर ऑफ 1 बिट्स हो तो तुम्हारा 1 आ जाएगा, तो तुम्हारा 0 आ जाएगा. हाँ, तो तुम्हारा 1 आ जाएगा. अगर इवन नंबर ऑफ 1 बिट्स हो 1 1, तो तुम्हारा 0 आ जाएगा. सही है. मतलब जोर में अगर 1 और 0 है, इसका जोर लोगे तो 1 आएगा, बट अगर वहीं पे 1 1 रहेगा तो 0 आ जाएगा. स्वीट. So yeah, this was the question. So moving on to the next one. Okay, so minimum cost to split an array. Okay, so you are given an array integer integer array nums and an integer k. So okay, so split the array into some number of non-empty subarrays, or cost of splitting is the importance value. Okay, so let's see what is the importance value. So trimmed subarray be the version of subarray where all numbers which appear only once are removed. Like if you have a 3, 4, 3, 6, 8, 4. So number appearing once, that is 6 and that is 8, it will be removed. So you'll get 3, 4 and then 3, 4. Yeah. Okay, so importance value of subarray is k plus just a second. Uh, yeah. Okay. So importance value of a subarray is k plus trimmed array length. Okay, so let me explain what this is. So let's say you are given any k value be let's say 3, and you are given an integer array is 1, 2, 3, 4, 6, 4, 3. Okay, so what will be the trimmed? Okay, if you are taking the trimmed array, if you are trimming this array, just remove the elements occurring once. Is one occurring once? Yeah, remove it. Is two occurring once? Yeah, remove it. Three, I see two, three. No, don't remove it. Four, I see two, four. Don't remove it. Six, yes, definitely. So it will be three, four, four, and three. And we are taking it dot length. So what dot length will give us? The length of this subarray, obviously, it will be 4. So the importance value or IMP value will be 3 plus 4. That comes out to be 7. So this is what it is. Okay. So moving on to the next part. Return the minimum possible cost of a split of numbers. Okay. So we have to return the minimum possible cost of split of numbers. Let's take an example here. It is I've been given k as 2. Okay, let's take k as 2. And then let's take the integer arrays 1 to 1, 3, 3, 1, 2, 1, 2, 1, 3, and 3. Okay, cool. So this is what it is. So if I trim this, how can I trim this? If I trim this, I see one appearing thrice. Great. Okay, move your eraser faster. I'll move it afterwards. Okay. So I see one is appearing 1, 2, and 3 times. Okay, so I cannot remove one, sadly. 2, 2 is also appearing 2 times, so sadly 2 cannot be removed. And then 3, the same way 3 is also appearing twice, so sadly 3 cannot be removed. So what is our length? 3 plus 2, 5 plus 5 plus 2, 7, I guess. Yeah, it will be 7. And if I return the IMP value, what will be the IMP value? 7 plus 2, 9. It will come out to be 9, which isn't the minimum because it is given. So here possibilities exist. Possibility. So whenever there is possibility, there has to be a recursion. And wherever there is a recursion, there can be DP. DP is nothing, just implementation of recursion in a smarter way. Okay, so we can split this sub area. So let's split this. Just keep it here. This will do. Yeah. So I can split this. You know, I can split this in smartly and reduce the sub array cost. So what if I take the first sub array to be 1, and then 2, and then 1, and the second one, what if I take 2, 1, 3, and 3? So if I choose this one, if we trim this after trimming, so after we have trim here, it will come out to be 1 1, and this one after trimming will come out to be 3 3 3 3. Okay. So if I trim this, the importance value of this will be 2 plus 2, which will give to me 4. And for this, in the same way as the question says, like if I split the array, for every split, the importance value will be individually calculated. So I had trimmed this, got trim किया, then इसकी importance value IMP value, what it will be, k plus the length of the trim, so 2 plus 2, 4. So the total value will come out to be 8. I find this is the minimum. So let's move to the code, to understand it in a better way. So, or let's take one more example, like if I have 1 2 1 2 1 2. So if I see here, there are 3 ones and there are three. The number of ones are 3, and the number of twos are 2. So the importance value of this whole subarray would turn out to be 7. But now if I split this in 1 2 and then 1 2 1, then here the importance value will be 0 plus 2, which will be 2, and 1 2 1, it will come out to be 2 plus 2, which will be 4. So the total importance value will be 6. So we have to smartly, split the array. So for that, we have to keep a track of, which sub array gives me the minimum value of the trim. So exactly that is what I did here. So moving on to the code itself. So I guess this was the main function given to me. So what I did, I calculated for every, no, I made a 2D grid, and if this is I and this is J, so for every, okay, so sorry for the disturbance. Let's continue from where we were. So what I'm doing here is I'm making a grid bana and I and J. So what this grid is giving me, the subarray length, the trim length for subarray from I to J. Like if you have, let me just open this. If you have, let's say, an array, okay. So this is the ith index, this is the jth index. So the trim length from I to J is given to me by this trim length 2D array. And then what I'm doing is I'm just hashing every value. हर value का एक hash निकाला, देखा. I am just seeing that if it exists, if it does not exist, then simply uh, incrementing the hash value from 0 to 1. Otherwise, if it exists, okay, so if it exists, like if I found 1, and if I found that previously also I encountered a 1, so total count here will increase to 2. Am I right? Yeah, I'm right. So what I'm doing is just if the hash value of the element that I encountered is already present and it supposedly be 1, so I am incrementing the count by 2. Otherwise, I am incrementing count by 1, because if I encountered 3 and 3 times, then it will be like 3 goes to 4. You are getting it. And just that trim length of I comma j, I am assigning it to count, and then a vector dp. What dp does is from the ith position, like you are given an array. So from one position to the other position, it checks out every subarray. Every subarray it checks out and finds the minimum for every subarray. And if it has a minimum, it will return it. So moving on to the solve function. So what solve function does, this is the the primary thing for primary condition, the base condition. If Like for every index I am iterating, because this index is the for every ith index. So what I am doing is, if the index increases my array size, if it comes here, then it's not valid, right? So I'll just return 0. Otherwise, if if the array index is not -1, it's some value, then it has to be the positive smallest value, that the value for the trim length for that subarray. So okay, then what I'm doing is, I'm assigning a min value that will help me find the minimum value for that particular subarray. So if I am doing the splitting, so this is what it is given in the question for I plus 1th index, or the ith index to the last n. Traverse करना है, and then as it is given here that for every importance value is equal to k plus the trim length size of what? The trim length size of the new array, the one we have found after splitting. तो उसको बस ऐड कर देता जाना है, मतलब कि ये क्या दे रहा है, इंडेक्स से लेके आय तक के सब एरे का ट्रिम लेंथ साइज, ये रिटर्न कर दे रहा है. ट्रिम लेंथ है क्या? ट्रिम लेंथ इज बेसिकली repeated stuff gets in, and no, the distinct stuff gets out. तो ये हो गया. फिर आई एम चेकिंग फॉर द I plus 1th sub array. If I split it, let's say if I have a sub array, तो अगर मैंने इधर का चेक किया, फिर अब मैं इसके ऊपर रिकर्सिव कॉल मार दे रहा हूँ, क्योंकि इसको मैंने स्प्लिट कर दिया है. अब इसको स्प्लिट करूंगा, हो सकता है इसमें से एक स्प्लिट और आए, दो स्प्लिट और आए. तो दैट आई एम चेकिंग, एंड फॉर एवरीथिंग आई एम कॉलिंग अ मिनिमम वैल दैट गिव्स मी द मिनिमम. व्हाट विल बी टोटल? अगर हम दो सब एरे ले रहे हैं, तो इसका इंपॉर्टेंस वैल्यू I1 है, इसका इंपॉर्टेंस वैल्यू I2 है. तो इफ टोटल क्या होगा? I1 प्लस I2. अब मिनिमम फाइंड करना है, तो क्या करेंगे? I1 प्लस I2 का मिन ले लेंगे, और फिर क्या? रिटर्न ऑफ DP फॉर दैट इंडेक्स. So this was the question. So that's it. Thank you for watching.